3, 2, 1. Oh, snap! Oh, God! What? In all of my experience of learning things, the two most powerful learning moments have always been when I got a result I didn't expect, or when I finally understood something I was sure I understood before. Today, no matter what you think about free energy, I hope to give you one of those experiences today. So, you've seen the title, you know what this video is about. Let's jump right in. Now, this is actually part 3 in a series of videos I'm doing on free energy. And if you haven't seen the first 2 videos, I'll put thumbnail images right here, links in the description. If you haven't seen those videos, then I need to get you up on why I'm the person answering this question and the stuff that we've covered so far. For several years now, I've been making all types of videos about electric motors, about generators. I've designed and built custom motors and generators, not just for this channel, but professionally as well. And I also love teaching this topic. It's one of my favorite things to take something as a somewhat mystical and exciting, even to kids, they love playing with magnets, and using that curiosity to teach people about engineering and science. It never dawned on me when I first started doing this that people would abuse that same curiosity to scam people. This really bothered me at first, and so I started making videos to explain these free energy scams we keep seeing on YouTube. The whole punchline being they're really just trying to steal your attention. They don't actually have a product that produces free energy. Why is your attention valuable? Because advertisers will pay for your attention. Now that you have that background knowledge, it's also worth pointing out my own attitude coming into this particular build. I get messages every day about free energy. Lots and lots of emails, hundreds of comments, all basically saying the same thing. Jeremy, what about this energy device? What about this free energy device? You see, the conversation usually goes something like this. They will say, Jeremy, what about this device that you probably haven't seen before, but I've seen it 100 times? And then I will reply, it's a scam, it doesn't work. And then they will reply, but Jeremy, you haven't built a thing. Why don't you build a thing and prove that it doesn't work? You can't know until you make it. And then I will reply, how is it that you think I need to build it in order for me to know it doesn't work? This drove me crazy. Why is it that people think you need to build it to know if it works? For me, it's like watching a magician pull a rabbit out of his hat. I don't need to know how the trick works to know that the rabbit did not materialize. There's something called object permanence. You know the rabbit didn't just come out of thin air. There must be a rabbit hidden somewhere. Therefore, I know it's a trick without knowing how the trick works. Why don't other people experience that? And then it dawned on me, wait a minute. It's because I see it as a magician pulling a rabbit out of a hat. And that doesn't make sense to you right now. But I promise, after I build this project and you see what happens, you're gonna understand all of this. It'll all make sense, I promise. I just need to show you a little bit more context first. So several weeks ago, I set out a plan to attack this project. What I decided to do was search my comments and emails and figure out which channel was recommended to me the most. It turns out it was Hidden Technology. I went to that channel, I found the video that had the clearest instructions where you could see every wire that went in, the instructions were very clear, and the device appears to work in the video. So I said, you know what? I got it. So my logic goes like this. If he's lying about that one video, then it's unreasonable to believe that the other videos are true, right? If you're not convinced, it's not because of the science, it's because you just really want to believe it's true, whether you have evidence or not. And that's perfectly fine. Hope is not illegal. You are allowed to hope that somebody will come up with a free energy device one day. This is all the stuff that I was thinking before, right? And so that was my plan. And then I started building this thing. I've got so much more I want to say about the results, but it will make so much more difference if you go through this build journey with me first, and then I tell you my thoughts. Now, if you want to get a lot of comments on YouTube, bother one of these guys. I wonder why. Feel free to leave a comment and tell me why. All right, I've collected all of the items we should need to build this thing. I've got 2 transformers, which have come from microwaves, as indicated in the video. I also have this, an asynchronous induction motor, which is what he describes in the video. This is pretty much identical to what he had in the video, with the exception that this motor is slightly larger. Okay, the one that he shows in the video is 0.75 kilowatts. This is 1.5 horsepower, which is more like 1 kilowatt, maybe a little over 1 kilowatt. So we have a slightly more powerful motor. Hopefully that'll give us some good results. It's also worth mentioning that inside his video, you see screw terminals inside of the motor. So you know, those are only there for convenience of wiring. They don't serve any other purpose in the motor. Now I have a whole series of instructional videos about how to wire motors, how they work. I have an introductory series, like motors for absolute beginners. And then I also have some more advanced ones. If you're interested in being able to do things like this, I frequently get emails from people saying like, how do you do what you do? I mean, that's why I make videos, to show you how I do what I do. So there are links to those videos in the description. All right, that's T1. Motor's wired properly now, so let me plug in. Here I'm controlling the motor with a VFD and a foot pedal below the table. That's why you see the variable speed. This is just to prove the motor actually works. All right, so the RPM is 3,400 RPM. I didn't confirm the RPM on the one from the video. It's possible that he's using a 4-pole motor. Shouldn't make a difference for our experiments. All it really means is that the shaft spins faster on this motor than on his motor. Okay, let's take this guy apart, and wow, I suddenly felt a little bit depressed. I actually don't want to take this motor apart for this, but we're gonna do it. It's for science, right? Right. Okay, I've made all the parts and we are ready to put this guy together. Here we have a synchronous AC motor, 220 to 240 volts, which is what he's using in the video. I had to order this because this is the one that came out of my microwave that you just saw me disassemble. It's 120 volts, so I purchased this one just to make sure we have all the same stuff. In the video, he is using what appears to be an alloy steel polished. So I'm using the same thing here, tapped exactly the same way. We've got our 2 coils from our microwave transformers. Let's get it all screwed down and wired up, identical to the way he wired it in the video. Ladies and gentlemen, we are ready to go. I'm actually kind of nervous and excited. This is fun. Everything is wired up and ready to go. I've got my multimeter here. Ooh, almost forgot the magnets. That was a big deal in his video. So we've got magnets here. I'm going to plug in my multimeter so that we can see if there's any voltage being produced. And we need some kind of indicator that this thing is actually working. So I made this little light bar, or I didn't make the light bar, I just made a cable for it. And we're going to use this to indicate whether there is power or not. So obviously it should light up if this thing works. In the video at this point, all he does is crank this synchronous AC motor here. You'll see voltage on the multimeter, and then we should also see power being produced. Lights come on and so on, right? Okay, dang, let's just do this thing. Oh, actually, wait. This is a fantastic spot to tell you about my sponsor today, KiwiCo. Ever since my kids were little, I've been looking for ways to get them excited about the things I'm excited about, like engineering and making things. 4 years ago, I was at a friend's house where my kids were playing with their kids, and we all got introduced to these little crates made by KiwiCo that are based on STEAM concepts. These little things are really creative. They're designed specifically with kids in mind. They've been tailored to the kids' interest and their capability level so the kids can put them together by themselves. I remember the very first crate my youngest daughter got was this little stuffed animal frog. And man, she played with that thing all the time. But it was more than a stuffed animal. When you open it up, there were organs inside, and there was a whole instructional book that went along to talk to you about the internals of this frog. I thought it was really creative and inventive. And it's not just biology. There are whole lines based on art or based on making, or the Eureka line is my particular favorite. And you can approach this a lot of different ways. At my house, I get everyone a crate, and the whole family will sit down together and put these crates together so that we can have this family time and also, you know, get to tinker and play together. But you could also just hand the box to your kid and let them go to town on their own, and they'll have just as much fun. It's also the holiday season, so you may be interested in getting this for the grandkids, for your nieces and nephews. You can buy these crates individually, or you can sign up for a subscription and have a new crate come every month. However you decide to approach it, I think this is one of the best investments I've ever made in my kids. If you want to sign up, and I strongly suggest you do, you can go to kiwico.com/fielding50. That's kiwico.com/fielding50 to get 50% off of your first month's crate. You'll be glad you did. Okay, for real this time. 3, 2, 1. Oh, snap! Oh, God! What? Either you were very excited there for a moment, or you're wondering what the trick is. All right, ladies and gentlemen, just in case you still aren't 100% sure, I was faking that. That did not actually happen. And I did try to do it the way that he did it, and this stupid thing didn't work, and I didn't expect it to. Although actually, the results were worse than I thought. So I think that's really interesting. First, before I tell you what I thought would happen, show you what actually happened, and show you how I faked it, I want to talk to you about transformers. Because to me, what's most interesting about this whole project, this is a Variac, a transformer. I want to talk to you about why this feels like it should work. Why do scammers love this so much? We've got transformers, we've got permanent magnets, there's an induction motor, there's a power strip that's plugged into itself. And somehow if you just have some sort of input source to get it started, then it'll just keep running itself. And they all have that. There's a few other things that they normally throw in there. So there might be pulleys. Gears and pulleys are pretty much the same thing. There will be step-up transformers. There will be AC to DC converters, things like that. All of these gadgets have the appearance of power, but none of them actually increase power. This is where the biggest misconception is. And this goes back to my analogy earlier, again, why I'm so excited about this video, about the rabbit being pulled out of the hat. You know, people are very comfortable with cars. Most adults know how to operate a car. You know what a steering wheel is. You know the accelerator, the brake. You know that when you put gasoline in, that somehow energy in the gasoline is converted into motion and the car moves. But if you picked an average driver from any country and had them explain how is the energy in the gasoline converted into motion at the tires, well, that's where things get a little bit more fuzzy, right? They might not fully understand internal combustion engines, And this is the mystery I want to take away, because there's a step in between. This transformer is what the power is going through. The same way that gasoline is going through the engine and coming out as mechanical power, energy is being pushed into this transformer and energy is coming out, but it's not increasing the power. And I'm going to prove that to you. When you understand how a transformer works, and I prove to you that that's how it works by actually measuring the input and output, you won't ever be scammed by a transformer again. And that is the part I'm so excited about. And let me be super clear. This has nothing to do with intelligence, right? I mean, unless you have a degree in engineering or science, the last time you heard about conservation of energy, let alone the details of how a transformer works, was probably in physical science in middle school, and maybe you took a physics in high school. But amongst all the things that you learn, how much of that do you actually remember, right? It's perfectly normal to not have a full grasp of this. Today, I get the luxury of fixing that. So here we have a Variac. Variac is a brand name. This is a transformer, an adjustable transformer. If I want something to run on, say, 80 volts AC, then I can plug this into the wall. I have 120 volts coming into this transformer, and I'll have 80 volts coming out on the output. If it's true that changing the voltage changes the power output, then what should happen is that the power output should go down, right? Because the voltage went down. That's not what happens, but just go with me for a second. If I turn the voltage up, then I'm increasing the voltage, and so I should have higher power output on the output. Well, we're going to measure both and see what happens. Now that you can see everything, let me explain the setup here. Here's a watt meter. This is measuring the power being drawn from the wall. Power, or in watts, is equal to voltage times current. Right now you can see the watts is 0 because the transformer is off and there's nothing plugged in the transformer. If I switch this over to voltage, you can see I have about 125 volts coming from the wall. The transformer is off, so the voltage, the current is 0, and the watts should also be 0. When I turn the transformer on, this transformer is adjusted so that the output's about the same as the input. All right, so let's go back to voltage. We have 125 volts coming in, roughly. And over here, you can see there is 126 volts. Maybe I can knock a volt off of there. All right, so again, roughly 125 on the output, 125 on the input. If you look at the power draw, that's in watts, you can see it's 0. But if you look at the watts over here, it's 60 milliamps, and the actual watts is 7 watts. So that tells you right there, I've got 7 watts coming into the system and no power going out. That means that this guy is already wasting some power. It's not doing anything except running itself, right? And there's no noise. There's a very low power draw just from having the transformer plugged in. But here's the more interesting part. When you plug something into the transformer, I'm going to start drawing power now. You can see that the light comes on. I'll leave that like that so it don't mess with the camera. So now we have 19 watts, almost 20 watts being drawn by this light. But look over here. The power draw went up by how much? Exactly the same amount, right? Actually, just a fraction more than what's going out. It went up by 20 watts, and we're just under 20 watts being used. But it also tells you that this system is interconnected. So when I started demanding more power from the system, it's coming from the wall. That's what we see here. Now here's where the magic happens. This transformer can adjust the voltage, right? So we've got 124 volts coming in and 124 volts going out. I'm going to turn this pretty much all the way, as much as I can get, about 150. So we've got 154 volts now, 124 coming in, 150 coming out. Let's look at the power draw. Power draw is about the same. Interesting. How about over here? Look at that. Power draw is about the same. The amount of power I'm actually using did not change. Well, what happened? So we got 125 on the input, about 125 on the output, and the current in milliamps is 165. So if the formula holds true, when I cut the voltage in half, I should get about double the current, right? Well, let's see. We're at 165. If we take this down to 60-ish, 61, 62. And you can see the power draw is the same. We're still at 20 watts. Power draw over here should be the same. 28 watts, actually wasting just a tiny bit more power. We're from 27 to 28. And look at the milliamps. We went from, I think it was 160. I already forgot. But we're at 330. And without even knowing the number, I know that that's about double because mathematically it always works out. There's obviously tiny differences in getting the voltage exactly right. But that's the beauty of engineering in general. Once you can apply the math to it, then the behavior, the behavior is consistent. It's the same every time. There's a couple key points I want you to remember. Number one, the input responds to the demand on the output. If we increase the demand on this side, let's say I plug more things in, you'll see this number keep going up because the transformer, when you put a demand on the transformer, like this is pretending to do, it will also put a demand on its input. But if there's no input, then there's nothing to supply power. But you can see those numbers will go up in relation. And also every component you add to the system will waste a little bit of power. In this case, this transformer is very efficient. It's only wasting about 7 watts. So let's get this out of the way. This is weird, but hopefully it'll make sense in just a moment. So here we go. Let's say we have volts over here, amps over here. All right. And the orange Play-Doh will represent our volts. And we're going to add some amps to it. And so now this mashed up thing is my power input, right? I'm taking this power. So that's on the graph. All right. So let's just say that up here, this is 100 volts. And right here, yeah, that's close enough. 5 amps. All right. This is what transformers do. They take this and they mush it, all right? And they do this. So now we have 50 volts and 10 amps. It's the same amount of power being put in. Nothing's been added. In fact, just a tiny bit is lost operating our transformer. That's the system right there. This, more impressively, is exactly the same for mechanical systems. So power coming into our gearbox. Over here we have something called torque, which I explained in great detail in a previous part of this series. And over here we have speed. And then this is our input power. And we're going to say this is, 100 Newton meters of torque. And then over here, we got 100 RPM. You take that power that was put into your system, you run it through your gearbox, and you can get more speed. 200 RPM and half the torque. You did not get more power. So here's a thought experiment that I want you to consider. Let's say I take a little kid's tricycle and I put the world's biggest gearbox on that tricycle, and I'm going to have this little kid compete in the Tour de France. The kid only has so much power he can put into that gearbox, right? So there's my kid's total power input. What the gearbox is going to do, it can give him more speed, but he's going to lose torque, right? And so because he's lost a torque, that means he's going to have to push considerably harder to maintain his speed. Or vice versa, if you use the gearbox to give the kid more torque, then his speed is going to go way down, which means his legs are going to have to fly many times faster on the input in order to be able to compete in the Olympics. It doesn't work. You win the Tour de France by having more power than your components, not by having more torque or more speed. So if you didn't get all of that, here's what I hope is the clincher for you. If you have a bicycle, go out and push the gears all the way down to the lowest setting. That's going to give you the maximum amount of torque output and the lowest speed. what you're going to notice is it's very easy to pedal, but you got to spin your legs really fast in order to get any kind of speed at all. And that's because the power requirements are being pushed back to the input. You, the user, your legs. If you switch it around, push it all the way up to the highest gear, please, for the love of God, go try this. You're going to notice it is extremely hard. You need way more torque on the input to turn that pedal. In order to get the same power output, that is speed and torque on the output, you're going to either need a lot more input torque or a lot more speed. This is all gears do. They give you a choice. It doesn't give you a power advantage. It gives you a mechanical advantage. In fact, this same basic concept is true for everything in engineering. There is always a trade-off. You want to add flywheels? There's a trade-off. Speaking of trade-offs, one of my all-time favorite questions that comes up in the comment section for each one of these videos, why don't we just cover the whole car in solar panels? Wouldn't that give you infinite range or at least greatly increase the range? Wow, what a fantastic question. I would love to talk about this engineering problem because it's an interesting one. 2 companies have gone bankrupt trying to solve this problem. It's a really hard and very interesting problem. It's not that engineers aren't thinking about these problems. It's just that the more time you spend thinking about the problem, the more problems you find. So we just learned that not only do gears and pulleys not increase power, they actually waste a little bit. And transformers, the same thing. They transform the energy into something more useful. Maybe I need more voltage or more current, but they don't increase the power. So here's a really simple way to evaluate any free energy device that has one of these components. If you take a power source, here's all my energy input, and I dump that into a transformer, right? Well, in the transfer process, I'm going to waste a little bit of power as indicated by the spillage here. But my cup is also leaking because our transformer was leaking 7 watts continuously. If I let this keep going on, I'm going to run out of energy. The same is true for gears and pulleys. Transforming mechanical power through gears and pulleys, not only do I waste some energy in the transfer, it's also continuously leaking out because gears rub together. There's friction, there's heat being created. Let's say I want to add a flywheel to my system. Same thing. Putting the energy into the flywheel, I'm going to waste a little bit of it. And it's going to continue to leak out. Flywheels are basically mechanical batteries. They take kinetic energy and they store it as momentum. The energy is slowly leaking out through friction, through heat. Same thing. Motors are converters. They take electrical power and they turn it into mechanical power. But they also leak energy. Motors warm up, they vibrate. It makes it easy to evaluate any one of these devices because if you have a flywheel, you have a transformer, you have a gearbox, you have any of these components, you already know now because you just learned they all waste power and none of them create power. So bam, you can now evaluate free energy devices without testing them. And we also learned another general principle in engineering. It is almost always better in engineering to have fewer components, not more parts that can break and give you problems. All of them are subtracting and none of them are adding. So there's no such thing as adding more devices to compensate for the loss of a previous device. Sometimes people will say, well, instead of 1 alternator, which is wasting some power, add 2 more alternators to make up for the first one. Well, now you just have 3 alternators wasting power. None of them are helping the problem. All of them are hurting the problem. So hopefully by now you're convinced that to get any power out of a transformer, you're going to need some kind of power being supplied to it. And the transformer can't supply its own power, because it's wasting some of it in this infinite loop. If you plug this transformer into itself and the transformer is using 7 watts continuously, then there must be a continuous supply of at least 7 watts to keep the transformer on, okay? So that part is completely debunked. And but one of the things that I found interesting about this is a synchronous AC motor, and you don't need to know what that is to know that this does work like a generator. If I crank this shaft, then I've got mechanical power input, me turning it with my hand, so I'm the power source. I turn, wow. Okay, be careful, Jeremy. Whew, I literally just shocked myself. Okay, I just pushed current through my hand. Wow, whew, that made my heart jump, sorry. Fortunately, I don't have that much power in my hand. Okay, so keeping my hands away from the terminals down there, if I turn this shaft, not only is it a little bit hard to turn, but there is power being pushed, electrical power being pushed through these wires. And so what I expected to happen when I cranked this is I thought the bar would light up just for a brief second. I thought, you know what, it's a LED light. Surely I can push, 10, 11 watts through this system in a quick turn and get the light to come on briefly. And I should also see voltage on the display. In fact, this only spins at like 6 or 7 RPM. No, it's even slower than that, 4 RPM. And so if I can spin it briefly faster than 4 RPM, then I should get the corresponding voltage, which is 220 volts. I'll get 220 volts to show on the meter. The light will come on briefly, and that's what I expected to happen. What actually happened was nothing happened, because when I turned this, that power wasn't just going to the light. It was going through my multimeter, it was going through both of these coils, and it was going through this huge, massive coil here. The energy was being dissipated and wasted in so many places, I could not even get the light to turn on. And so literally nothing happened. I cranked it, and even more importantly than that, there was pushback. Because all of these systems were drawing power, it was very difficult for me to turn this. God, it's so much harder to turn. My fingers were literally hurting after trying for like 10 minutes to crank start this thing and get the light to come on, because I was really hoping I could show you the light coming on and tell you like, hey, see, I'm producing the power. The energy is coming from me. But apparently I'm not even strong enough to dissipate the wasted energy from these parts here, as well as get the light to come on even for a few milliseconds. And it's also worth pointing out that this is probably by far the most important part of the induction motor. And he took this part out. Without this is just a huge coil of wire. It's not actually doing anything. It's the relative motion between the AC current flowing through these wires and these aluminum bars that go around this. I have a whole video just on this called Nikola Tesla's greatest invention. It was this guy. You should check out that video. Anyway, this part of the design is pretty much useless without this. So the only way I could fake this, now getting to the interesting part, is I actually had to disconnect this power bar inside of this box. So everything else is still connected, except the power strip is not connected. I also had to disconnect this motor from the power strip, because guess what? If there's power on this strip, 240 volts, this motor should spin. It doesn't spin in his video, but we all know intuitively without thinking about it that the motor should run when electricity is on the motor. Because it didn't spin in his video, I disconnected mine so mine wouldn't start spinning in my hand and ruining the trick. But this is one of the fatal flaws in this idea. It can't feed power back into itself. In fact, if that worked, then you should be able to just connect these two wires together, spin the motor, and then it should auto spin because it's powering itself. Now that comparison may sound a little ridiculous to some of you who are used to thinking of the transformer, the permanent magnet, or these various components as adding power to the process. But once you realize they don't add power, you realize these two ideas are pretty much identical. In fact, all you've done is add an extra long cable in between and wasted a little bit of the energy in the process. So I would argue that shorting the wire across there is actually smarter than adding another device in between, which will itself waste some of the power along the way. And there's one more thing that I had to do. I needed a real power source. So what I did was I edited the footage so that even though there was a power strip plugged in here, you couldn't see it. You didn't see the plug because I recorded footage of nothing being here. And then inside of Adobe Premiere Pro, I cropped out that little section and I'm showing you old footage of the thing being unplugged while it's actually plugged in. If I wanted to move this around and make it even more convincing, then I would probably switch over to After Effects, and that would give me more flexibility in how I could morph and move the image so that you would never see the cable. I also don't want you to get too hung up on the way that I approach this problem. It doesn't have to be footage editing. It can be physical tricks as well. I mean, I could have drilled a hole on the inside of the motor up through the bottom, let the cable go down through the table, and as long as I didn't move the thing too much, You would never see the cable. The cable is just hidden from view from the camera. I also could have taken one of the other plugs and let it serve double duty, that the cable hang off of the table, and where it's hanging off the table, I could splice in a power cable. There are so many ways to approach this. As long as it's out of view, that's all you need. That's how close-up magic works. They don't need to edit the footage. The visual effect is happening right in front of you. The point that I'm trying to make is I don't want you to get too hung up on how they did it. I just want you to think about what you're seeing versus what you normally see in the real world. If this seems to be too good to be true, it's because it probably is. The other thing that's super easy to forget, you're not watching it in real time. They can show you the events in whatever order they want. They can try as many times as they want. If they didn't nail the shot the first time and a cable was exposed, they can try again. If they want to show you something as being empty and there's a thing inside of it, then they show it to you empty first and then they add the item. Or vice versa. They can add the item, shoot all the footage, take it out, and then record more footage of it empty. But you don't know what order these things were shot in. One of my favorite examples of this is Zach King. He is amazing at visual effects with the camera moving around, and these shots are very convincing. You feel like he fell through a pool table into a pool. But because you understand object permanence, you know he didn't actually fall into the table, right? It's because you understand the physics of that. But if I take the physics of something you don't understand quite as well, it's a little bit easier to trick you. Now, we could argue about whether I did a good enough job, hiding the fact that it was plugged in, or whether my acting was very good. I think it was terrible. Nobody's gonna pay me to be an actor. But none of that matters. What makes this so effective is you don't have to be quite as good as somebody like Zach King. You can just watch a few tutorials and you'll be good enough. Those tutorials won't make you as good as Zach King, but you don't need to be, because part of the scam occurs in the viewer's mind. They already hope it's true, so they're a little bit primed. The information is a little bit fuzzy. The person on the other end of the camera is very confident. They're showing you something that appears to be working. They sound like an expert. You have no reason to question them, and you have no reason to suspect them, right? You can't immediately see how they benefit from this. They're not asking you to send them any money. It doesn't trigger any of our normal reactions to, the possibility of being flim-flammed. And so what I'm trying to say is it's very easy to fall for this. Actually, we can generalize this and say that anytime you combine a poorly understood topic with a strong human desire, you've got a recipe for scams. I mean, think about it. It's why we have stock market scams, because the stock market is poorly understood. It's why we have dating scams, because women are poorly understood. It's why we have free energy scams, because we all want free energy. In fact, the only thing you want more than free energy is food, which is literally energy for your body. Think about what I'm saying here. And that's really the whole goal of these YouTube channels. They are cash cows in the sense that they will build a free energy device, and then that video will run its course, and then they need to make more money, so they will tweak the design a little bit and then make another video. And the trend that you'll see is that the entire channel, every video on the channel, is about that one topic. Now, it doesn't mean that you can't have a channel dedicated to the stock market that's legitimate or whatever. But what I'm saying is just be aware that when you see those kinds of patterns, that it might be worth verifying that what they're saying is true and that they're not just trying to waste your time and steal your attention. Now, for many of you, this is a completely new revelation, but this scam is actually very, very old. When I was researching this video, I found newspaper ads from the 1800s where people promised to send you plans for a free energy device that you could build at home. You mail them the money, they mail you the plans. You can imagine how this turned out. Quite frankly, if I didn't find this so unethical, I would say that this scam is genius. What makes it so genius is you don't even realize that something is being taken from you. I mean, how do you even quantify the stealing of someone's attention? The person feels no loss. You only experience loss right now as I'm telling you that something was taken from you. And so I'm making you really uncomfortable talking about this, and I know it because this is your first time realizing that, wow, maybe I was actually tricked. And that's very uncomfortable. Nobody wants to believe they've been tricked. And so sometimes people react by saying things like, yeah, but but I watched the video. I'm sure that that's what happened. It's like, I don't know what to tell you except that it doesn't exist in the physical world. And if it did, this invention would be worth hundreds of billions of dollars, literally. And yet this person is just sitting on the design. I've even had people email me and say things like, actually, we already know this exists, but the government is covering it up, or companies like Tesla don't want self-driving or self-charging cars because then they can't charge you to plug into their Tesla station. But if you just take a few minutes to think about what you're saying, that's entirely ridiculous. We charge people for all kinds of things that cost nothing at the government level and at the company level. You buy bottled water. Bottled water is a billion-dollar industry, and guess what? Water is essentially free and readily available in a lot of places. But we pay for it because of the packaging. You are going to tell me that you wouldn't buy a free energy device? You're going to tell me that you wouldn't pay a maintenance fee to keep your free energy device working? Come on now. To me, that doesn't make sense. Even at the government level, here in the United States, probably in most countries, but at least in the United States, I pay hundreds of dollars a year for a little sticker that they put on my car that gives me the privilege to drive on the road. A road I paid for with tax dollars. That sticker costs nothing, and I paid for the road. Come on now, the government can't charge me for a free energy device? You or your landlord pay property taxes every year for the same dirt that's been there since you've been in that house, for the same building that you've already paid for. I feel like if you think that people can't make money off of this, it's because you just haven't thought about it very much. You just are excited about the idea that it's a conspiracy. Guess what? Strong human emotion combined with a poorly understood topic. I know I'm making you very uncomfortable right now, but that's what the truth is. Somebody has just given you this idea, it got you excited, but you didn't calm down and actually think about what was being said. There are a lot of ways to make money off of this, and there's no reason to cover it up or pretend it didn't happen. What's missing is the engineering. It just cannot be done yet. I am certain that we will come up with all sorts of ways to create more efficient energy sources. Like, inventing is what I do for a living. I create devices that don't exist yet. So it's not beyond me to think about things that haven't been imagined yet. I spend all day thinking about things that don't exist yet. What I'm telling you is there are logical, measurable, repeatable reasons why these devices don't work the way they're being portrayed in these videos. And it's because that's within my capacity to measure it and know it doesn't work. Now, I've been calling this a scam all throughout the video, but I feel like I need to pull that back just a little bit because in reality, there's all sorts of misleading drama on the internet, Jerry Springer-like videos with baby mama sleeping with uncle's cousin, whoever. And the thing that bugs me about this, or what used to bug me at least, is just that it's pretending to be science, which is measurable, repeatable. And that's the part I don't like. At least on Jerry Springer, there's a chance that this random dude really slept with this other person's whoever. And so you can just be lost in that drama, and some people will believe it and some people will just think it's entertainment, and both of those things are fine. This really isn't very different from that, and I just think it's worth backtracking just a tiny bit and acknowledging that for some people this is indeed entertainment. There's room for all sorts of content on the internet. I am by no means the arbitrator of what should and shouldn't be posted. I think the worst I could say is that perhaps these people are ethically more flexible than me. But I feel like it's intuitive that when a person clicks on a sci-fi video, they're expecting the laws of physics to be defied. But when they click on an engineering video or a documentary or something like that, they expect to see what actually happened. And all I'm asking is, if you're going to blend those two things, that you make it clear that that's what you're doing. To me, that would be the most ethical way to approach this. So here's the big learning moment that I experienced while making this video. I've been thinking of the concept of free energy as this plague that needs to be eradicated. But it could actually turn out to be one of the most powerful tools we have for teaching people. Think about it. Thousands of people, maybe even millions of people will watch this video. I think I've been missing out on a huge opportunity to teach people about real engineering. And maybe I should change that. Thanks for watching.